So this is where we left off. We were talking about the LaRue method versus like the old school methodology. So these are your homework assignments, right? I'll do 5 problems. There's 5 sections. So let's get some problems written up. We've got 30 minutes to knock these out real quick. All right, number 6. Somebody give that a read for me, please, and thank you. 6p squared. Okay. So real quick, a couple of you from the homework, we're still having issues. Remember, if it says solve, that means that you have to end with the variable equals something and the variable equals something, okay? If it says factor, then that just means that you put it into parentheses. So you got to keep that straight in your mind. So what do you notice about this? What's the lead coefficient? Is it a 1? It's a 6. So what we're going to do is we're going to use the LaRue method, right? Is everybody okay with LaRue? Okay, so I'll just go with the LaRue. Personally, just so you all know, if this were me, I'd go old school on it. Just because what's the coefficient on C? So it's got to be 2 numbers that multiply together to get 6, I had to get 5. So it's a 3p plus 1 and a 3p, 3p plus 1 and a 2p plus 1. Okay, if you don't see that pattern, then stick with LaRue. So what's the first step with the LaRue? Multiply A and C. Everybody good with that? Now what do? We factor like normal, right? So give me 2 numbers that multiply together to get p squared. P and P. I need 2 numbers that multiply together to get 6, but when you add them, you get 5. 3 and 2. All right, the sign's going to match and be different. Match, and they're both what? Positive. Okay, if I multiplied by a 6 at the beginning, can I just randomly multiply? No, so now I have to divide, right? So, the first thing that I want to do is check and see if things can reduce. So, 3 over 6, can that reduce? Yep. To what? 1/2. Yep. Okay, 2 over 6, can that reduce? Yeah. To what? 1/3. Okay, did I get whole numbers here? No. So what do I have to do with these denominators? Move them in front with the variable, right? So we're going to get 2p plus 1 and 3p plus 1. And we are factored. Okay? And again, if you're not sure if you're factoring right, what can you always do? Just multiply these together and you better get right back up here. So you can see 2p times 3p is 6p squared. 2p times 1 is 2p. 1 times 3p is 3p. 2p plus 3p is 5p. And then 1 times 1 is 1. And we actually have the original statement. That's a lot of p's running around, yeah. Everybody good? Yes, no, maybe? Number 15. Please and thank you. Minus 16? Okay. So, again, what do you notice? Is there anything that's jumping out at you? Anything at all that your brain looks up here and goes, ooh? What is? 49 is a perfect square, 16 is a perfect square. What else do you notice? There's no what? There's no b. Whenever there's no b, when there's no middle term, the only way that can happen is if the numbers match identically. One's a positive, one's a negative. Everybody okay with that? Yes or no? Okay. So I need repeats. So what number times itself will get me 49x squared? 7x. What number times itself will get you 16? 4 and 4. Now this is where I have to be careful. I can only use this if there's no middle term and c is a negative, right? Because what's a positive times a negative? Negatives, right. In order to use this, I have to get negative signs here in the parentheses, which means that I have to have a negative sign on c. And you're done. All right, so recognizing patterns can be pretty big in factoring. And that's kind of what we're building on, is taking those skills, okay? I hope that you recognize that this is more than just some mundane task. And it's not magic, okay? It's just pattern recognition. 23. What's 23 say, please? And thank you. Plus 16. Equals 0 or just that? Okay. So there's a couple of different ways of doing this. 18 and 16, are you going to really want to multiply those together and find factors? You can, but things get really big in a hurry, right? Yep. Well, you can't square root 18. 18 is not a perfect square. But what you can do is you can factor, okay? So if you're looking at big numbers and your brain's like, oh my gosh, that's big, then say, okay, brain, stop. Is there anything that I can pull out of all three pieces? So is there any number in common between 16, 36, and 18? 6 doesn't go into 16. 4 doesn't go into 18. 2, that's it, right? So that leaves me with 9z plus 18z plus 8, right? So you're close, because 3, but not there. So, everybody good? Okay, so a little bit smaller, right? So what we're going to do is we're going to use the LaRue method inside, but we can't just get rid of this 2. We don't get to just randomly remove stuff. So it's going to stay outside. Okay? So you're going to have 2 times it's going to stay outside with parentheses. Everybody good? So what's 9 times 8? Whoops, a daisy, as I screw up. And that's a squared, by the way. So now I need 2 numbers that multiply together to get 72, but when you add them, you get 18.
Is that 72?
Yeah. I need 2 numbers that multiply together to get 72, but when you add them, you get 18. 9 and 9 is 81, so that's not going to work. 9 and 8, what's 9 plus 8? 17, not 18. So you have to make one smaller to make one even bigger. So 12 and 6? Well, 12 and 6 is 72. So there you go. So if you're sitting here going, I don't know how to do this, do you understand that when you're factoring, you can spend a lot of time playing around with factors, right? If you get to where your brain doesn't spit out an answer, if you look at 72 and 18 and go, I don't know off the top of my head what works. What you do is you start with factors of 72. So we're going to take 72 and we're going to take 72 and divide it by 2. Just start in the basement and work your way up. 2 plus 36, is that 18? Clear it off. What's next? 72 divided by 3, is that a factor? 24, can I take 3 and 24, add them and get 18? No, that doesn't work. 72 divided by 4. That's 18. Can I take 18 and 4, add them and get 18? Okay, 72 divided by 5, is that even a factor? No. 72 divided by 6 gets me 12. Is 6 and 12 18? Then you've got it. So I don't want you up here guessing, okay? There's a lot of opportunity for mistakes with factoring if you're just up here guessing. We do have systematic approaches that you can use. Some of them take a while, okay? That one took a while to go through all of the combinations, right? But would you rather go through all of the combinations knowing that you're not repeating yourself, or just sitting there trying to track it all mentally going, I hope I got everything? That's the difference, okay?
Rather just go calculate.
Okay, so it might take a little while, but it guarantees you don't make a mistake, right? And this is our answer in factored form. And we're done. Okay? Yeah. Ta-da. Oh, wait, no, we're not. Yeah, this is the LaRue, sorry. Whoopsie. No, the 2 can stay outside because it asked us to factor. So that's cool. But I forgot that I'm using the LaRue method, so if I multiply it by 9, I have to divide by 9, right? So what's 6 over 9 reduced to? 2/3. And 12 over 9? 4/3. So what happens to the 3's? Go in front. So I get 3z plus 2 and 3z plus 4.
Is your 2 still on?
Yep. If you want to, you can kick them inside to one of these and get 6z plus 4, but you don't have to. Because 6 times 3 is your 18, but if you FOIL this out properly, it will get you right back up to the top because we divided the 2 right off the top from all 3 pieces. Okay, number 32. What's number 32 say? Okay, there's a couple of different ways of doing this. I'll show you the long way, which is... Yeah, I'm going to show you the long way because it'll match more along what we've already been doing, okay? And then for those of you that are more advanced with your mathematical manipulation, I'll show you that side too, okay? So if I ask you to solve something, what's the first thing you have to do? Not yet. What you said equal to 0, the what's? The F word. The factors. So when they ask you to solve, your first step should be factor. So how do I factor this? So what do you see? 16 is a perfect square, 1 is a perfect square. Is there a middle? No. The only way we can get no middle is if we have exact numerical similarity in both factors. One's a positive, one's a negative, right? So the pattern is no B and a negative on C, then I just square root the numbers, and I have to repeat. So what gets me 16x squared? And what gets me 1? One's a positive, one's a negative, right? Now that I've factored, what do I do to each piece? Set them equal to 0. And this is where, when we did 4.3, I warned you, don't just flip the signs, right? And this is for that situation. So to solve, what must I get by itself? The variable, right? So in the first factor, how do I get x equal to 0? What's my first step? Subtract 1. Divide by 4. So x equals negative 1/4. How do I get x by itself here? Add 1. Divide by 4. And there's my second solution. Everybody okay with that? So when they ask you to solve, your process should be factor, set each factor equal to 0, isolate the variable. Okay? Now, what I was going to say before is, do we have a middle up here? No. So if I just asked you to solve, what does it mean to solve? Get what?
So those are
Get the variable by itself, right? Yep. So those are our two answers. So if I give you this statement right here, and I said, all right, get x by itself. How could you get x by itself in that? What would be your first move? Add 1. And then, and how do you get the squared by itself? Square root. Square root the entire thing, plus or minus the square root of 1 over the square root of 16, which gets you plus or minus 1 over 4. Now, why didn't I show you that way first? Simple. We haven't covered that stuff yet. So that's only if you remember it from last year. If you do, fantastic. That's chapter 5. If you don't, we're going to get into it. Yes, sir.
no.
Only if B is not present. If there's a B, this doesn't work because there's no way to isolate the x's and the x and the x squared without factor. So it's only if you see the pattern. No B, yeah, go ahead and run. All right. Was that 23?
Yeah.
Or was that 32? All right. What was it? Okay, so again, what I've tried to express to y'all, the language is actually important here. So when you see the term zeros, right, what are the other three terms that mean the exact same thing as zeros? We have zeros, x-intercepts, roots, or solutions. All four of those mean the same thing. So when you see zeros, your brain should think solution, right? Or sorry, should think solve. When you see the term zeros, it means the exact same thing as just solve the equation. Okay? Intercept form. Anybody remember from 4.2? What does intercept form actually look like? Huh? Yeah, what is intercept form? What does that mean? No, that's slope intercept form. This is intercept form of a quadratic. No. Standard form, y equals ax squared plus bx plus c. Vertex form, y equals a, parenthesis, x minus h, parenthesis, squared plus k. Anybody remember intercept form? Y equals x, well, yeah, there's an a out front, a, parenthesis, x minus p times x minus q. So when they say find the zeros by writing in intercept form, what does this look like? What's the other term that we use for this style of a presentation? No, not FOIL, but factored. So they're really just asking you to factor the quadratic and then solve it. but they're using the terms of zeros and intercept form. So if you don't know the language, there's an opportunity here for you to do a whole bunch of work that's not accurate. Yeah, A, B, and C are the coefficients. So after all of that, we're going to just solve this. I just wanted to make sure that we're good on the language. Because again, the number one killer on the ACT is not the math. It's that you don't understand what they're actually asking you to do. Alright? So that's why I spend time going over the language. If you can dissect what they're saying and put it in terms you know what the action is associated with, then you can be more successful on the ACT. Okay, so how would you factor this?
4.
Times the 4 with 5? Everybody okay?
Yep.
Okay, and then what? Okay, factor with A, so you get x and x. And then two numbers that multiply together to get 20, but when you subtract them, you get 19. 20 and 1. Are the signs going to match or be different? Different, and the bigger number is negative. So what's the bigger product? X times 1 or 20 times x? 20 times x is bigger, so it gets the negative. This gets the positive, right? For the LaRue, what's the next step? Divide by 4 because we multiplied by 4. Okay, can anything in here reduce?
Yeah.
Okay, so what's 20 over 4 reduce to? Okay, can 1 over 4 reduce? So what happens to the denominator? Okay, so this is this part of the requirement. It says solve the quadratic equation by rewriting it in intercept form. This is intercept form. Everybody okay with that? Yes or no? Right, so now we have to solve. So how do I go from intercept form to solved? So another name for this style isn't just intercept form, but it's also factored form. Okay? So set each factor equal to 0. And then how do I get x by itself here? Add 5. So what's x equal to? 5. And then here, what do I do? Minus 1, divide by 4, so x equals negative 1/4. And these are your two solutions, and you're done.